Let's have a look at the Matrix product. There's quite a few benefits in design. Let's just have a look at them first. So with the Matrix, this one has a smaller strut on it from carbon fibre. So it's really for a lower activity level of patient and really for isolated drop foot weakness. It's made up from carbon fibre and glass fibre. The reason for that is that we can have different textiles to make it more durable in some areas and then more flexible in others. For example, when a patient comes through into heel strike, you want to be able to have some good shock absorption. The patient then needs to progress over onto the brace and have support, but then when they go over onto their forefoot and are going into the initial swing phase, they need to have a bit of flexibility. If we have a look at this here, you can see that the front of the brace is then more flexible compared to the middle. If you have a look at the foot plate on the Matrix, you can see that we have a higher heel compared to the forefoot. The reason for this is that most shoes have a pitch. This can be roughly 10 millimetres, where you have a height at the back of the heel compared to the ball, and it also has a bit of toe spring in it as well. So what we've done with the actual foot plate is designed so that it lies more flush inside most lasts of shoes. Another design feature we have on the Matrix is that we have this height adjustable front. Here you actually use Allen keys, so you can then make it either taller or shorter. And this again, because it's off the shelf, you want that kind of versatility with a patient to have it slightly longer or shorter. The Matrix is an off-the-shelf product, but we can actually customise this to fit the patient a little better. Now it ranges from size small all the way through to extra large, which we reference through footwear sizing. What you can add with the Matrix, for example, would be a low-profile insole. If you have a patient who has mild pronation or supination, you may want to have more control of the calcaneus, midfoot and forefoot. Therefore, you can actually add on top of the foot plate an insole, either prefabricated or custom-made, to your own prescription depending on which patient clientele that you have. So the makeup of the Matrix, what we have is two straps. Now these are Velcro closure to make it easier for a patient to apply and also to take these off. What we have on the inside is a foam liner. Now, the foam liner lies against the shin to give a little bit of cushioning. This actually can be removed because it's in with Velcro also. Because it's in contact with the skin, we always provide a second one to then change, and the patient can change this within a couple of days and keep it clean. Let's have a look at the alignment of the lower extremity in the device. What we're looking at here is the anterior tilt of the tibia. This should be approximately at 10 degrees inclination forward to mimic normal biomechanics in gait. If we don't have 10 degrees of inclination forward, what we could look to do is provide, for example, a heel raise, whether inside the footwear under or over the Matrix device, or we can consider using a rocker sole adaptation on the footwear. Let's have a look at the Matrix being fitted onto a patient. The first thing we do is select the size of the foot plate length. With the device comes a flat insole with double-sided tape. Remove the backing and then this can be fixed onto the foot plate. By altering the position of the insole in relation to the foot plate, the position of the lateral strut can be moved relative to the lateral malleolus. One option with footwear is if they have an insole that comes as part of the shoe, this can be used instead of the insole provided with the device. Then we put the device into the patient's footwear and don the entire lot as one piece to make it easier for the patient. Once in place, we're going to adjust the anterior shell. You loosen the screws by turning them to the left. At this point, you want to set the height of the anterior shell approximately 1/4 to 1/2 inch below the patella tendon. Once in place, then tighten the screws to the right. And at this point, the Loctite that are on the screws will keep them in place. Once we have this, you'd want to don both straps, doing the distal one first and then the proximal. You need to ensure there's decent tension on these to actually hold the device against the patient's leg. You then want to fasten the footwear, whether that's Velcro or laces, with decent tension, and then the patient is ready to walk in the device.